In this lab, we will import, we will read the file buildings underscore wc.gpkg. So, so read data buildings equal gpd dot read underscore file open bracket and then the name of the file. And when we display the building's data frame, it looks like this. So it's a geo data frame. It's not just the data frame, it's a geo data frame. So it has subject locality, town, city, territorial authority, LQ, SUS, SA2 name, and geometry, which is multi-polygon. So if we print the suburb locality, the list of the suburb locality, so we get, insert the cell, and we want to display the unique values of suburb locality. So buildings dot suburb locality underscore locality and unique open and close bracket. And when we run that, so it's not identifying suburb locality, so we have suburb underscore locality, suburb underscore locality, so it's SUB. So there is a spelling mistake here. Let's remove R. And okay, so in the suburb, we get Atara, Karamea, Maruhia, Totraflat, Moana, Inangahua, Ikamatua, Upper Bula Gorge, Westport, Berrytown, Dobson, Carter's Beach, and so on. And if we look at, we insert another cell and we display unique values of another column, display unique values of, let's display unique values of town's city. So let's look at what town it is from. Okay, so this is how we do that. We'll pass the command buildings dot town underscore city unique open and close bracket. Okay, so we get the town, this empty space, which means that this data was not entered, so it was left blank. Then we have Westport, Greymouth, Granite, Lunanga, Riften, Hector, Hokitika, and Ross. Then we plot buildings. See, it plots. So it plots these dots over here. This is where the buildings are located. And let's plot, let's find the CRS. And CRS is using EPSJ 2193. So the coordinate system is consistent with the rest of the coordinate system. So it's all good. And the visual check. So background map equals south underscore island dot plot, color equal light gray. So when we run this, it's the gray background of South Island, and then once we have plotted the background using South Island dot plot color equal light gray, on it we plot buildings dot plot, and then bracket. We'll use the axis equal background underscore map, close the bracket. So if we run that, okay, so in the background map, we see the buildings located where the Alpine faults are. So we are looking at the buildings located where the Alpine faults are. That's the high MMI areas. Let's display these buildings. So we have already gone through it, and there are 47,108 observations containing 6 columns. We have liquefaction subsibility values of here, column. Then we have 47,108 rows. This will be interesting to work with. Let's have a look at the locality. Okay, so what we're doing over here, we'll insert a separate row and buildings. So let's look at the geodata frame of buildings, and then we look at this one here. So dot log of this. Then okay. So what we are doing is that we are looking at the hockey tika. So hockey tika, suburb locality is in hockey tika. So we want the suburb locality. We want to subset all those rows which are in hockey tika. Okay, so what we can do is we can subset from buildings. What we are over here doing is showing only the data rows for which the suburb subset suburb underscore locality equal hockey tika. Okay, so suburb locality equal buildings suburb locality equal hockey tika. So we subset those rows and we see, okay, so there are 3,133 rows and with the 6 columns. So let's look at what this function does. This function should also do the same thing. So let's insert another cell and let's check this. This is another way of subsetting. So subset suburb locality suburb locality equal okay ticker. Okay, so refresh this. This should give us the similar kind of thing. This plotted, so we don't want that, we want the data. So buildings, okay, so we get 3,133 rows and 6 columns. So it's the same thing. So we can see it's the same thing. And then we plot it. So dot plot. So those we already have the geometry. So it will plot. So the buildings are plotted over here. You can see that. And let's plot this building on the background. So we already did that over here. So let's copy this and let's insert a new row and we paste that. Background map equal South Island. So we first have the background map and we want this. So we'll put this. The subset of it. So buildings, so we want only the subset part of it, and we want to plot with the background map. So let's do that. Okay. So so what has happened is that let's let the subset part equal temp equal, right, and then we'll do instead of typing all this, now we have the geodata frame containing Hokitika data only. So in temp geodata frame, so we will have temp and plot that, and it plots that, but it's very light, and I guess it's not visible. Let's put the color equal red. Let's see if there is some improvement. Okay, so we can see that the red marks are over here. So it looks like it's around this place over here. Okay,